Now, permit me now to switch to the WEKA environment. We're going to use a very simple problem solution, very simple problem. I'm opening a data set. We are using this data set. Yeah. Now, you can see this data. This is a data set example. Is set of data sets to actually diagnose if someone is diabetic or not. But this time around, using questionnaire. See, this data is freely available online, by the way. You can pick it up. See, the idea is you can see there's age. These are the attributes. There's age. You can see age. You can see gender, male or female. So you have the polyuria, polydysplasia, sudden weight loss, weakness. You see, and also of other questions. We will not want to take us to those medical jargons, as they call it. Obesity, alopecia, and also of others. These are questionnaires prepared for some people in an hospital. So, and the target class is positive or negative. Positive means is diabetes, negative means no, not diabetic. Now, so we have the data set. You already get your data set. You already got the data set. And then the next is to open our WEKA. So you can see here, you see, originally when we open WEKA, this is it. Yeah. So once you work with your WEKA, you see Explorer here. You click Explorer. By the way, you have other tools in WEKA. So for exploration of how WEKA was, kindly you can refer back to our earlier videos on our YouTube on how to use WEKA with Excel, how to load data from your Excel. All this we discussed earlier. So because of time, we have to make all these references so that we can cover the most important parts. Now, you see there's a tool here called Package Manager. If you click that Package Manager, it will display so many other tools, even tools that were not yet installed on your WEKA. You can install it from there. It's very powerful. Even now, WEKA support deep learning, which was not there before. You can go to Package Manager, click it, search for deep learning, and you can install deep learning on your WEKA. So we want to work on the Explorer level. Click this Explorer. The experimental is a little bit more, higher a little bit. Yeah, thank you very much. So the Explorer, once you click the Explorer, this is what you get. You can see here, let me take it now. This is our Explorer. Now, the first stage, you can see that all the other tabs are gray out. It means you cannot use these tabs. You can't use these tabs because of what? You didn't have the data. The first step is to put your data in. Open file. So you have to go to the location of your file. I think my location of the file, let me see, my location is, I just downloaded the data to their place. Yeah, downloads. You see, it's not seeing it. In the download, it's not seeing it because I didn't do something. It's looking for ARFF data file because the default file format for WEKA is ARFF. However, my data is in Excel file. I like to work with the Excel file. So I need to go in here and select CSV. You select CSV. You can see CSV. Select CSV, so we come up. You see, this is data set. This is data I'm looking for. Just click it and open. You can see my data is in WEKA now. So these are your attributes already imported for you. You can see nice visualization here. You can click it. The air, you can see the analysis. You can see my mouse. This is analysis of your age. Minimum of age is 16. Maximum is 90. Mean. These are very important statistical information you have to provide when you are doing machine learning research, especially when you want to report. You see, because in machine learning, you need to report. Even if you are not a researcher, you need to write a report of what you have done, how you did it, the optimization you have done, so that people can know how to repeat your experiment in case the client wants it to be done again. But for people who want to publish, this is compulsory. So documentation is part of machine learning. Either you are working as industrial-based guy or you are working as an academic. Now, so once we have the data in, you can see the gender. You can see anyone you want, 8 male, 192 female. So you can, this is the class, positive 320 positive people, negative 200. It means the data is not balanced, but not too bad. 320 against 200, that's fine. It is when you have 400 against 10 or 5 or 20 or 50, we say, wow, the gap is too much. But this is still acceptable. But sometimes if the result doesn't work, we can try to do what we call balancing. We balance our data to make them to be equal by reducing the one that is more, or by increasing the one that is little. By doing what we double the data. Of course, this is introducing fake data, by the way. I don't like it, but sometimes we don't have option, we have to use it. But I prefer to reduce the number of maximum, the one with maximum and many values. I reduce them so that I don't have fake data. But it is acceptable also to do the repetition. Now, once you have loaded your data, the next thing you can see, this is now possible for you to do. You can work with it now. We'll go to classify. See? This is where you're going to select your classification algorithm we are talking about. Click here. You are going to see your, we want to use k-nearest neighbor. It is called lazy. We told you before, it belongs to the lazy category. It's a lazy classifier. You click here, you can see IBK. The name is WEKA. You can see, just put your mouse on it. It will show you, you can see the kind of information. Just over it, it will tell you the name. This is k-nearest neighbor classifier. It can select appropriate value of k based on cross-validation. You see the description? Click it. We have selected IBK. So now we are ready to build the model. Your first model is about to be ready, by the way. The next thing for you to do is to select how do you want to break your data. You know, you have to divide your data into two, testing and training. There's another type we didn't have time to mention earlier. We call it cross-validation. This is when we break data into 10 parts, and then we run the experiment in 10 places, and then find the average of the results. We use this, data is very few. We've had data from material science that are only 16 samples. 16 samples. So we don't have enough to divide to 2. We use validation, 5-fold cross-validation. We have opportunity in future to discuss all this in details, and we also have it in some of our video available earlier. But for this one, we want to demonstrate with division into 2. So percentage split. We call it percentage split. So we want to split the percentage into 70% for training. We don't specify the remaining is going to be testing, by the way. So when you put percentage split 70, it means choose 70% of the data, and we are going to use for training, and the remaining 30% use it for testing. You are ready to go, by the way. Now you just click go, and it will start running. Just click start. k-nearest neighbor will start working. It's done. You can see this is the result are here. Correctly classified instances. Out of, now you can see 146 and 10. What that tells you, it divided the data into 70. It used the result of the 70% is used for training. The result you are seeing here is for testing, because usually we don't really need the testing result, the training result, because if you get 100%, without seeing the testing result, it is useless. So what is displayed here for us is the result of training. You can see it shows us all the attributes used, and then tell us this is the percentage accuracy. This is the what we call the confusion matrix. Okay, this is class A, class B, positive and negative. This is correct classification. 96 are A and they are classified A. 50 are B and they are classified B. However, there are only 8. These are mistaken classification. The one that you see on the diagonal and the left diagonal is misclassification, mistakes. 8 are supposed to be in A, they put them in B, and 2 are supposed to be in B, they are put in A. This is where we have false positive and false negative. But with this, you build your first machine learning algorithm. And yes, machine learning model. Now, so having this, now the next thing I would want to point out because of our time is once you build it, you have built the first one. However, someone might want to ask, what if I want to see the result of training? Then you need to go here, more option. You go inside, you say output model for training split. Can you see here? You see, because it's hiding it. We don't need it, by the way, because we only want the testing set. But if I want it, I'll say, okay, output. Show me the output of model for training. And I'm going to close that place and I'll run it again. You have to build it again. At that point, it's going to show you the result, training, and testing together on this particular space. Now, so we have seen that. The next very important thing I want to mention is we have VK nearest neighbor. We have only built K nearest neighbor K to be equal to 1. And I told you to do optimization, compulsory. So you cannot just report the result. Of course, we are getting 93% accuracy is not bad in medical. It means I can predict who is having diabetes by questionnaire by 93%. So I go here, I click it. I can change that my KNN to 3. Let's try 3. So run it again. It becomes 91. Strange. It means the performance goes down. I better go back to my 1. So I need to keep checking again. Maybe 5 will be better. What is wrong somewhere? This is called optimization. I want to make sure I've used the best one that is possible. 89. It is working for me. I go back 1 because the result keep down now. You can check for 11, 13, 17, if as K may be, and you can make a plot to let people know what you have done. So I run it again with 1 because it's giving the best. We have 193. You need to remember, I told you about the nearest neighbor distance measure, including distance used. Can I use another distance? Why don't I try Manhattan distance? Maybe it's going to be different. So I change it to Manhattan distance and I click and I'm going to run it. Here you go. We got 93. So I change different distance measure also to see if I'm going to get better result or otherwise. This is the simple way of doing optimization in KNN. And I hope it's very, very clear at that point. So this is a very short demonstration of WEKA.